Assalamualaikum and good morning. Welcome to EH2208KK Nafas Industries. Thank you for coming. Today we are going to present on design project for production plant that produces 32,000 metric ton per year of 1-propanol. This project is supervised by Dr. Nor Idris. Firstly, I would like to introduce our team members, which are Nurul Nadiana, Sharmieza Kasmi, Nor Asyraff, Firdaus, and Syaharizan Maulud. Today, we will be covering 5 topics, which are process integration, process control, design of major equipment, economic analysis, process safety, and plant layout of production plant of 1-propanol. Hi, I'm Nurul Nadiana. I will be discussing on the process background and site selection for this project to help you improve your understanding regarding this topic. So let's get started. So what is propanol? Propanol is widely used in the industries as solvent to produce products such as hand sanitizer, thinner, and antiseptic. The chemical formula for 1-propanol is C3H8NO. The application of 1-propanol includes pharmaceutical, chemicals, personal care, and other. Based on Malaysia's Department of Statistics, the import amount of 1-propanol in 2019 is 32,000 metric ton per year. However, during this pandemic of COVID-19, the demand of 1-propanol has increased drastically. This is because the need of alcohol-based hand sanitizer. The product specification of 1-propanol produced by our company has 98.8% of purity, 0.2% of water, in a liquid state and completely soluble in water. The process chosen to produce 1-propanol in our plant is OXO process. There are 3 raw materials, which are hydrogen, ethylene, and carbon monoxide. Hydrogen, ethylene, and carbon monoxide will be first fed to reactor 1 to convert to 1-propanol. Next, it will be sent to vessel 1 flash separator to separate carbon monoxide and hydrogen and pass into reactor 2. So reactor 2 will produce 1-propanol. So 1-propanol will be passed into 2V102 will separate carbon monoxide, and the bottom product will be sent to distillation column. In the distillation column, it will separate the unwanted gas at the top product, and the bottom product will be 1-propanol desired. All the carbon monoxide and hydrogen gas collected will be sent to V102 flash separator 3 to separate light end and heavy end product. Site location of 1-propanol production plant is located at Pengerang Industrial Land in Johor Bahru. Because the location is strategic, it is very near to raw material supply, and it is easier to transport end product. Now I will pass to Nor Asyraff to present on the process integration in the 1-propanol plant.
Assalamualaikum. My name is Nor Asyraff bin Rahman, and I would like to present on topic of heat integration, which is chapter 7. First of all, this is the process flow diagram before integration is being done. And as you can see here, the red line is where integration take place. And here is the process flow diagram after heat integration take place. The objective of heat integration is for improving energy efficiency, thus reducing operational costs on energy-related application. This is our temperature interval construction as well as our cascade diagram on the column that marked with blue box. The arrow in red color is our hot stream, while blue color is for cold stream. The temperature used in this table is the shifted temperature. As we know, in cascade diagram, we can actually know our QH mean and also QC mean. The above part is our QH mean, while on the bottom one is our QC mean. This show the threshold problem because our QH mean resulted as 0. Hence, this is our heat exchange network. As we can see here, stream H4 and C2 will shift heat among them, as well as stream H5 will shift the heat with C1, and both process follow heat exchange principle, which is for below pinch. CP hot must be bigger or equal as CP cold, and the temperature difference must be not lower than 10, because our delta T mean is 10 degrees Celsius. In our grand composite curve, we determine the type of utilities based on temperature. this mechanism, we refer to the book entitled Chemical Process Design and Integration. Type of utilities that we use is cooling water and also chill water. The amount for both type of utilities is 140 kilowatt and also 12 kilowatt respectively. Okay, here is the last part of this topic, which is the comparison between before and after heat integration take place. Our energy saving is 100% for hot utility, while for cold utility we can save up to 10.37 cents. So from here I conclude that our plant need heat integration as we can save energy requirement as well as reducing cost of operation.
Assalamualaikum and a very good morning to panel industry and all the lecturers. My name is Muhammad Firdaus bin Kamarudin and I will be explain on the first reactor in the production of 1-propanol.
The first reactor is hydroformylation reactor, which play the role to convert the ethylene, carbon monoxide, hydrogen to propanol with the catalyst of radium at the temperature of 190 degrees Celsius and pressure of 2655 kPa. The reactor chosen is multi-tubular fixed bed reactor with the length of 5.72 meter and the diameter of 1.43 meter that give the highest conversion per weight of catalyst compared to other type of reactor. And based on the chemical and mechanical design calculation, the dimension of hydroformylation reactor to produce optimum amount of propanol with 96% conversion can be known. And from this calculation, the volume of multi-tubular fixed bed reactor is 10.25 meter cube with a weight of radium catalyst of 2936 kg and the number of tube is 564 in the triangular arrangement. In the mechanical part, this reactor is made of stainless steel SS304 for the tube side and the reactor is oriented vertically with straight cylinder skid support made from the stainless steel 304 and have ellipsoidal head. For this reactor, it is important to control the flow of inlet stream. This must be maintained to ensure the continuous processing and achieve desired product composition. The flow rate can be maintained by manipulating the flow from the previous unit operation. For this reactor also, it is important to control the temperature and also pressure inside of reactor by constantly supply the cooling water to the reactor in order to maintain its operating temperature and pressure of the reactor. So, if there is no flow, low temperature, low pressure, even high flow, high temperature and high pressure in the reactor, the possible consequences from this situation will be the process will be stopped, that cause no product are coming out and may cause the desired product propanol does not meet the target from the reactor and can cause an explosion. This can be prevented by installing the low and high of the flow temperature and pressure alarm and frequently maintenance the pipeline.
Assalamualaikum and very good afternoon to our panel, especially to our industry panel. My name is Syaharizan Maulud. I will present to you about the design of reactor 2, which is the hydrogenation process. The next is the process background for this reactor. The type of this reactor is which is a packed bed reactor. The packed bed reactor must have the catalyst. The catalyst used in this reactor is nickel, and the operating temperature and pressure for this reactor is which is 120 degrees Celsius, and the pressure is 780 kilopascal. Then the process for this reactor is hydrogenation process. That means they have two inlet for this reactor. For one inlet is flow the hydrogen gas, which is pure hydrogen gas, and the other one is from the separator, which after we separate the undesired gas and we collect the desired gas and we transfer to the second reactor. And the limiting reactor that happen in the second reactor, which is propanol. Propanol is the main product for our reactor 2 because the reaction of the propanol and the hydrogen gas will form 1-propanol. Okay, next is the AutoCAD drawing. We can get the AutoCAD drawing after we do the sum calculation about the diameter, volume, length, and the mechanical design. From that, the type of vessel, which is we already know, is the packed bed reactor, and the material construction for this reactor which is the stainless steel 316, and the type of support is the 90-degree straight circuit. The operating pressure and the temperature is the same. This is 120 degrees Celsius and also 780 kilopascal. and the length of the vessel is 2.5 meter, and the diameter for the vessel is 0.85 meter. The type of head we use in this reactor is undecided, and the tube of specification, the number of tube that have inside the reactor is at the tube. Next is the process control. Process control is most important because to control operating condition, which is temperature, pressure, and also the flow rate for the reactor. Okay, for the inlet of the reactor, which is the carrier of the reactor, we use the flow control that control the flow rate of the reactor before flow into the reactor. And then at the outlet of the reactor, we use the pressure controller because the pressure must be under the operating condition. Okay, next we use the temperature controller. Temperature controller that we connected to the reactor and also to the outlet of the reactor. For the last slide is the process safety for the reactor. From the table, we can see the characteristic, consequences, and prevention. Okay. For characteristic, we have the three parameters, which is flow, temperature, and pressure. That it is speed to flow is low and high. Okay. For the low flow, process will stop and the possible explosion hazard. And then the high flow, desired product will not need the target. Okay. That's for the temperature. With low temperature, we keep the various composition because the change of product quality. And then the high temperature, the vessel will have pressure and it will be damaged. And next is the low pressure with the reasonable flow and the decline the reaction rate. And then the high pressure, it damage the wall of the vessel and possibly explosion.
Assalamualaikum. My name is Sharmieza Kasmi and I am going to explain about the design of distillation column T101. Distillation is a process in which a liquid and vapor mixture of two or more substances are separated according to their boiling points. T101 is a multi-component distillation column used to separate one propanol from other components such as ethane and hydrogen with purity of 98%. The feed stream with ethane, hydrogen, 1-propanol and propanol is fed at 20 degrees Celsius at 2.8 bar. Meanwhile, the distillate products leave the column at 100 degrees Celsius and 1.8 bar, and the bottom products leave the column at 116 degrees Celsius at 2 bar. Ladies and gentlemen, as you can see, the design of distillation column has successfully been carried out. After performing detailed calculations, the diameter and height of the distillation column is designed to be 1.5 meter and 19 meter respectively. By taking plate spacing of 0.5 meter, the actual stages obtained are 36 stages with the feed tray at stage number 13. Lastly, the material of construction used for this distillation column is carbon steel. Ladies and gentlemen, the objective of T101 control system is to control the purity of distillate and bottom products as well as to maintain a smooth operation. The control system of T101 is designed to maintain level, flow, pressure, temperature as well as composition. Feed-forward type controller is used to control flow to ensure that there is sufficient flow of components going into the column. Meanwhile, feedback type controller is used to control pressure and level to ensure that there is no overpressure or overflooding of components in the column. Lastly, cascade type controller is used to detect change in temperature and composition. The objective of hazard and operability study of T101 is to examine its operation as well as to evaluate problems that may be potential risks to employer, employee, and its surroundings. The first parameter is when there is low or no flow, which disrupts the purity of 1-propanol or even stop the whole production. Therefore, it is required to install low flow alarm and also to maintain the pipes to prevent blockage. The second parameter is high level, which causes overflow or flooding of components in the distillation column. Therefore, it is important to install high level alarm. The third parameter of T101 HAZOP study is high temperature due to malfunction of cooler. Therefore, it is important to install high temperature alarm as well as to maintain the cooler frequently. The fourth and final parameter is high pressure, which may cause backflow of process and even rupture of column that is dangerous to employer, employee and surroundings. Hence, installation of high pressure alarm is important as well as installation of pressure relief valve.
Assalamualaikum, and again me, Asyraff, will describe on design of aspiration vessel, which is flash aspirator. First and foremost, let us see the aspiration process involved in the aspirator. The inlet product is propanol, ethane and also carbon dioxide. These three components will enter aspirator instead of mixture. As we can see here, the bottom product is rich of propanol while for top product is rich of carbon dioxide. Next to me is the drawing of aspirator, which include of top view, remister pad drawing, the drawing of head and also overall design of aspirator. The short summary design for aspirator is the type of aspirator, which is vertical liquid vapor flash vessel. The design of temperature and pressure are 303 Kelvin and also 0.22 Newton per millimeter square. The height of aspirator is 4.0939 meter, while for the diameter of aspirator is 1.8561 meter. The volume for the aspirator is 11.0782 meter cube. The type of head and support is flat head and also skirt support. While for the material of construction of vessel and skirt support is stainless steel and also carbon steel. So next, I proceed to the process control system of this aspirator. First of all, this aspirator consists of three control systems as we can see here. Firstly, flow control system, pressure control system and also level control system. Pressure relief valve as the addition in order to control the amount of pressure in the vessel. Last but not least is the safety part. So this part I just put 2 of problem out of 4. The first one is if no flow to the aspirator, what will happen, and also the action taken to reduce or eliminate this problem. The consequence is mixture cannot be split efficiently and minimum level in the aspirator cannot be achieved. To tackle this problem, low flow alarm is installed at the feet of line. If high flow, explosion will happen, and to tackle this problem, high flow alarm will be the best consideration. That's all from me. Thank you.
Hi, I'm Nadiana. Today I'm going to present on the design of heat exchanger E105. So what is heat exchanger? Heat exchanger is a system that is used to transfer heat between two or more fluids. As for heat exchanger E105, it is a fixed tube shell and tube heat exchanger used to cool down process fluid from reactor 2 R102 before entering vessel 102 flash separator 2. The heat transfer fluid used for this heat exchanger is chill water. This is because we want to cool down the process fluid from 145 degrees C to 20 degrees C. And also one benefit about chill water is it is cheaper than refrigerant. The area of heat exchanger design is 14 meters square, and the heat duty required for this heat exchanger is 88 kilowatt. AutoCAD drawing for the heat exchanger 105 is as shown on the slide. After conducting chemical and mechanical design calculation, it is found that the number of tubes required for this heat exchanger is 44 tubes. The shell diameter for this particular heat exchanger is 276 mm. The tube outside diameter of 2 mm, and the length of tube of this heat exchanger is 4,880 mm. Corrosion allowance taken into consideration is 2 mm in this calculation. Head type of the heat exchanger is ellipsoidal head, and the baffles type is single segmental baffles. As for the material of construction, carbon steel is used to construct the shell side of the heat exchanger. Meanwhile, stainless steel is used to construct the tube side of heat exchanger. And the material for the insulation is mineral wool. We will now proceed to the process control for heat exchanger E105. Two control structure for this heat exchanger, which are flow control and temperature control. Flow sensor will detect the disruption in the feed stream. This data will be transmitted to the flow controller and then followed by the flow transmitter. Then the flow controller will control the opening of valve to adjust the flow rate entering the heat exchange. As for the temperature control, feedback controller will be used to control the temperature of stream 22. Temperature sensor will detect the disturbance and signal to the temperature transmitter. It will then forward the data to the temperature controller to adjust the valve at the inlet chill water stream. This is to keep the outlet temperature as close to the set point as possible. Process safety for this equipment is very important because we don't want any accident to happen. A study has been conducted to study the possible consequences and the preventative measure for the process safety of the heat exchanger. Possible consequences are high flow, low temperature, and high temperature. If the flow rate entering the heat exchanger is too high, it will lead to low thermal efficiency. If the outlet temperature of the heat exchanger is too low, it will lead to inefficient of heat transfer process. And if the outlet temperature of the heat exchanger is too high, it will lead to overheat and explosion might occur. Preventative measures that can be taken into consideration are to install a high flow alarm, to install a low temperature alarm, and install a high temperature alarm. Schedule and performing regular inspection is very important to maintain the process safety of the equipment. Okay, that's all for the design of heat exchanger. I will now pass the presentation to Sharmieza Kasmi to proceed with the economic analysis of the plant.
Ladies and gentlemen, the objective of economic analysis is to estimate the profit to maintain the business stability. In order to estimate the profit of our company, the difference between the revenue and cost of materials must be calculated. As you can see, the profit margin of our company turns out to be 97,651,501 ringgit. Therefore, our company has a positive profit margin, and it is safe to say that our process is profitable.
Some conclusion can be drawn after the economy analysis of the production of 1 propanol per year has been done. From this figure, it shows the plant operating life is about 12 years, with 3 years required for startup of the plant. This analysis also shows a payback period of the plant is about 3.41 year. This figure provides the cumulative discounted cash flow diagram for different discounted factor. It shows the effect of discounted factor on the profitable analysis, and the minimum discounted factor was set at 10% and the maximum discounted rate at 17%. Above the 70% of the interest rate, the value of NPV is equal to negative value. After the interpolation, the interest rate is about 16.16%, and it gives the value of NPV for this project is equal to 0. Which means this represents the highest after-tax interest rate at which the project can break even. According to the overall economy analysis of this 1 propanol plant, it can be inferred that this plant is economically feasible because it has best return on the expenditure. Thank you.
Hi, I am Nadiana. I will be presenting on the plant layout for this processing plant. Figure shown is the 2D plant layout constructed by using the AutoCAD software. The wind direction for this plant is south-southeast, and the processing area and non-processing area are separated to ensure the safety of the employees. I'll give you a quick review of the function of each component located in the 2D layout. Firstly, when you enter the plant, there will be a guardhouse. This guardhouse is to monitor the entrance of people and vehicles. Then, on the right side, you'll see a car park. This is to provide space for the employees and visitors to park the car. An office. This is to provide a workplace for any administrative and managerial work. Also, cafeteria located in the plant to provide food and drink for the employees and visitors. You'll see an assembly point in the middle of the plant to provide space for employees and visitors to gather in event of emergency. At the assembly point, you'll see a workshop, store, and fire station. Shop is to provide facility or keeping maintenance equipment, and the store is to store the equipment unused, and the fire station is to store the firefighting apparatus such as fire engines, personal protective equipment, and more. The electrical substation located on the top left of the plant is to distribute electricity into the plant. Also a control room to monitor and control the production process. There's two types of loading bay, which are raw material and product loading bay. Raw material loading bay is to load and unload raw material resin, and product loading bay is to load and unload 1-propanol product. And there's plant utilities and wastewater treatment plant. Plant utilities is to provide utilities such as air, water, and steam. Wastewater treatment plant is to treat the wastewater and remove pollutants. Okay, this is the video for production plant layout constructed by SketchUp software. This is in 3D. Okay, this is the top view of production plant, and this is the side view of the production plant. Okay, when you first enter, there's a guard house right there. Okay, I'll next zoom to the other space to let you see the dimension. And this is the car park, and this is the office of the plant. Okay, next I'll show you the wastewater treatment plant. Behind the wastewater treatment plant is actually our equipments. There's also a utilities building. Okay, that is all for the 3D layout for the production plant. Thank you for watching and have a nice day.